We have seen that if corresponding angles are equal, then that implies that triangles are similar. So if you have two triangles with equal corresponding angles, then I can say that these two triangles will be similar. We had also seen that when two triangles are similar, the corresponding angles are similar and the ratio of the corresponding sides is similar. Now we know that if the corresponding angles are equal, then that implies that triangles will be similar. So this alone is sufficient to prove similarity. Now what about the second condition? Would this alone be sufficient to prove similarity? Well, yes, it is, and let us see how. So if corresponding sides are proportional, I can say that triangles are similar. So if there are two triangles with ratio of corresponding sides is the same, or the corresponding sides are proportional, then I can say that the triangles will be similar. Now we shall try to prove this. What we know is that the sides are proportional. That is, AB by DE is equal to BC by EF, and this is also equal to AC by DF. So these are the three pair of proportional sides. What I want to prove is that these two triangles are similar. If these two triangles are similar, then the corresponding angles should be equal and the corresponding sides should be proportional. We know that the sides are proportional. All I need to prove is that the angles are also equal. So to prove that they are similar, I want to prove that the angles would be equal. So how do I proceed? So first, let's draw P, mark a point P here and Q here, such that AB becomes equal to DP and AC becomes equal to DQ. So now DP is equal to AB and DQ is equal to AC. Now let's join this P and Q. So we have this, we join P and Q. Now you already know that AB by DE is equal to AC by DF. This is given to us. Now I know that AB is equal to DP and AC is equal to DQ. So what I can do is, rather than writing AB and AC, I can substitute this by DP and AC can be substituted by DQ. So I'll write this as DP by DE equals to AC is equal to DQ, DQ by DF. So I get this, that DP by DE is equal to DQ by DF. So I have DP by DE which is equal to DQ by DF. Since the ratio of the corresponding sides is equal, I can say that these two lines would be parallel by converse of BPT. Since basic proportionality theorem states that if lines are parallel, it would divide it in equal ratios, and the converse says that if the ratio is equal, if you get equal ratio, then the line that divides it, which is PQ, would be parallel to the third side, which is EF. So I get PQ is parallel to EF by converse of BPT. Once I know that these two lines are parallel, I can say that the corresponding angles would be equal. So if these two lines are parallel, this corresponds to this. Angle DPQ is equal to DEF, corresponding angles. Again, DQP would be equal to angle F. Again, corresponding angles. You can easily spot corresponding angles by an inverted F. You can see an inverted F here. Again, you can see an inverted F here also. So these are corresponding angles. These two are equal. These two again are corresponding angles and will be equal. So I get this. So now we given that the ratio of the corresponding sides is proportional, and we know that these two lines are parallel and the corresponding angles are also equal. So in triangles DPQ and DEF, let's look at these two triangles now, DPQ and DEF. What do you observe? This angle is equal to this and DQP is equal to angle F. So I have one pair of equal angles, I have second pair of equal angles. if two corresponding angles are equal, I can say that these two triangles would be similar. Why? Because angle-angle criterion. By angle-angle criterion, I can say that whenever two angles of corresponding triangles are equal, the triangles will be similar. So I know that dpq is equal to E and dqp is equal to F. So I can say that these two triangles, dpq and def, are similar by angle-angle criterion. Once two triangles are similar, the ratio of their corresponding sides should be equal. So what we know is that dp by de should be equal to pq by ef. Corresponding sides, ratio of corresponding sides should be equal. So I get dp by de. So dp de and I get pq ef. So in these two triangles I can say this because they are similar. I can say this. Now dp is equal to ab. So I can say, since dp is equal to ab, I can say that ab by de is equal to pq by ef. I get this. But also I know that AB by DE is already equal to BC by EF. And I get AB by DE is equal to PQ by EF. So I get AB by DE is equal to PQ by EF. Also these two are equal. So AB by DE is also equal to BC by EF. Since this is equal to this and the same thing is equal to this, therefore these two should also be equal. So I can say that PQ by EF would be equal to BC by EF. Now I can cancel EF from both sides. So I can say PQ would be equal to BC. So if I cancel EF from both sides, I get PQ is equal to BC. So this is equal to this. Now let's look at these two triangles. So I want to prove that ABC is similar to DEF. This smaller triangle is similar to the larger triangle. What I've seen is that BC and PQ are equal. Now let's look at these two triangles, ABC and DPQ. This triangle and the smaller one here. What do you see? AB is equal to DP. I made it so by construction. AC is equal to DQ. And third side, BC is also equal to PQ. We just proved it. So, since the three sides are equal, what can I say? That the triangles would be congruent by side, side, side. So, by side, 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 I can say that these two triangles would be congruent. If these two triangles are congruent, I can say that they are similar. Since congruency implies similarity, if it's congruent, it already has that inverted S which signifies same shape. So congruent implies similarity. So if these two triangles are congruent, I can say that they are similar also. So I know that ABC is similar to DPQ. I also know that this small triangle here is similar to this large triangle because two pair of angles are equal and by angle these two would be similar. We've already proved it. So we know that DPQ is similar to DEF. So 1 is similar to 2 and 2 is similar to 3. So I can say that the first and third would also be similar. So let's call this as 1 and this as 2. So I see that 1 is similar to 2. Again, this 2 DPQ is similar to the third triangle here. 2 is similar to 3. So I can say that 1 would be similar to 3. That is, ABC would be similar to DEF. And this is what I wanted to prove, that ABC is similar to DEF. Now let us look at applications of this. So we know that if corresponding sides are proportional, then I can say that the two triangles are similar by side, side, side criterion or SSS criterion. So now can you tell me whether these two triangles are similar? That is, ABC is similar to triangle DEF or not? So I am giving 3 sides of this triangle and 3 sides of the other triangle. So knowing just the sides, how can I say whether the triangles are similar or not? I know that if 3 sides of one are proportional, if the ratios of the 3 sides of one are proportional to the 3 sides of the other, I can say that triangles are similar. So if ABC is similar to triangle DEF, what I know is that the ratio of the corresponding sides should be proportional. That is, AB by DE should be equal to BC by EF which should also be equal to AC by DF. So I'll find all these 3 ratios. If the three ratios turn out to be the same, I can say that the triangles are similar. So let's find AB by DE. AB is 6, DE is 3. So this turns out to be 2. Now let's find BC by EF. BC is 4, EF is 2. So again this turns out to be 2. Now let's check the third ratio, that is AC by DF. I know AC is 8 and DF is 4. So 8 by 4, again I get 2. So AB by DE is 2, BC by EF is 2 and AC by DF is also 2. Since all these 3 ratios is equal and is equal to 2, I can say that these 2 triangles are similar by SSS. This is a picture of a map which you see in your atlas. But do you think that this is actually the size of the world? The world is much larger in size, and this is just a small scaled down representation of the map of the world. So a map is nothing but a small 2-scale representation of the world. And what do you see here? This is the scale. This is actually the scale which says 0 and 1800 kilometers. That means that 1 unit on this map actually shows, this distance on this map actually shows 1800 kilometers in the real life world. So what you see is that triangles actually can form any shape. We've seen that polygons can be formed of triangles. So this map here is a rectangular map which again can be broken down into triangles. So similarity of triangles implies similarity of this rectangle also. So this rectangle in fact is a similar image of the world map which is scaled down to a smaller level. Similarly, engineers also use similarity a lot. Now, when they want to make cars, they would not directly make a huge model of car. What they do is, they make small scale models. They make a small car, check whether they can put everything inside, they check all the features in that, and only once it's approved in the small scale model, only then they build the actual cars. Similarly, it's not just for cars, but for aircrafts also. For every machinery, we make a small scale model and then we make it apply those changes in the actual model. So this is a small scale model of a car. Normally the scale model of a car is 24 to 26 centimeters only. So you can say this is the small scale model. It is 1/18th of the actual car. So it is 18 times scaled down image of the actual car. So 18 times smaller than an actual car, and hence this scale model is also similar to the actual car but 18 times smaller. The only difference is difference in size. Everything else is same. All the interiors are also the same. Similarity is also used by architects a lot. So it's not just these small toy cars or toy planes. From toy cars to actual cities and buildings, everything has to be first made on a small scale before they actually build it. So architects use these floor maps, which are called, so these are called floor maps. They are drawn to scale, so they make a small drawing, see what they want, and then actually go out and make the proper structure. So this is a floor model of a washroom. And you can say that 1/4 inch here actually shows 1 foot. So 1/4 of an inch in this diagram actually represents 1 foot in the actual size. When they'll actually go, they'll make 1/4 of this. 1/4 of this would actually be scaled up to 1 foot. So again, that's how similarity is used by architects too.